What did the scientists discover within the black hole? Does this necessarily mean that we're nearing the end of our lives? Today we'll look at what scientists have discovered inside a black hole. When it tends to come to the universe around us, one of the most frequently asked questions is, what's inside the black hole? There is an alternative description of a black hole known as the holographic description. It's as if there is a two-dimensional world that surrounds any given three-dimensional world, with the same physics as the three-dimensional world we're familiar with, but described in a completely different language. Because the gravity around black holes is so strong, it warps not only space and time, but also light and information. Nothing can escape the abyssal black hole once it gets close to it. Because of the secrecy surrounding their womb, black holes are the most strange occurrence in the universe. Light cannot escape their depths, but a black hole luring 6 galaxy clusters at once is incredible, and one 1,000 times the size of the Sun has done it by trying to spread its web 300 times the size of the Milky Way. However, we nevertheless realize so little about black holes that this may be the only tip of the iceberg. What if the black holes hide whole universes within them? And what happens if we do live in one of them? Scientists currently believe that the interior of a black hole is a spot where matter is condensed to an infinitely small size, and all concepts of time, space, and physics collapse into what we call a singularity. What if the singularity is more than an extremely small point of nothing and everything? What if it is a wormhole that connects two universes, or two distinct locations in our universe? What if each black hole houses an entirely different universe, or what if they are simply a glitch in the simulation we call our universe? Because of modern telescopes and our understanding of universal physics, thanks to great minds like Albert Einstein and Stephen Hawking, we now have a good idea of what happens on the outside of a black hole. As something approaches the infamous event horizon, the escape speed outpaces the speed of light. As a result, even light is trapped inside the gravity of a black hole. But now, because of the capabilities of quantum computers, we have something entirely new, some shocking data about the nature of these ever-hungry behemoths that are the main attraction of almost every known galaxy. What if I told you that the most terrifying objects in our universe are nothing more than illusions? No, we're not implying that they will vanish if you stop believing in them. A more complex solution is proposed by the University of Michigan research team. Black holes appear to be nothing more than holograms according to simulation studies conducted by the study team led by Enrico Rinaldi. No, not the kind is seen in science fiction movies like Star Wars. However, because holography is rooted in the concept of hologram duality, the term holography is used in a more scientific sense here, which is a mathematical hypothesis attempting to link particle theories and their interactions with gravity theory. Okay, that was a little too technical, so let's make it easier to understand. It all comes down to the lack of a single theory that can explain the entire universe. Einstein's general relativity theory states that there are no particles, only space-time, and thus it deals with the third dimension. However, the basic model of physics only deals with particles and completely ignores gravity. As a result, it is characterized in the second dimension. In terms of black holes, these two theories are meaningful in defining how they function. However, physics has struggled for over a century to discover a common ground for the two opposing theories. This is where Rinaldi and his team may have been successful. They used quantum matrix models to investigate holographic duality and link the two theories. By employing all of it, they know about particle theory and quantum theory of gravity. The plan was to use simple matrix models to build up blocks of numbers as a starting point for creating things using a framework similar to that used in quantum computers. Researchers were able to explain the gravity inside a black hole by running simulations with the models developed in the framework. The current concept of a black hole's interior is based primarily on gravity theory, which states that space-time moves through and within a black hole from the outside. But here's where things can get complicated. We can't calculate space-time on the inside of a black hole like we can an outside one. There is no proof of what happens inside a black hole. As a result, we must base our research solely on mathematical calculations. These calculations, according to Rinaldi, show that the best way to describe the inner process of a black hole is to compare it to a holographic projection. But how did they arrive at such an unexpected conclusion? To begin, let us define a hologram in this context. In this context, a hologram is a two-dimensional or flat image that can be displayed in 3 dimensions. We've all seen Michael Jackson helped bring to life in the shape of a hologram at the Billboard Music Awards in 2014, enslaved to the rhythm performed. By investigating the link between gravity theory and particle theory using quantum matrix models, researchers have described a black hole as a 3-dimensional entity. However, we can only see through it in 2-dimensional particles. However, this is still only a mathematical representation based on the most recent calculations. That implies that it is still only a theory. This is not the first time we've used mathematical equations to attempt to forecast the inner workings of a black hole. In another mathematical case, astrophysicists discovered that the singularity inside the black hole is a ring rather than a point. According to the Kerr metric, the geometry of a rotating black hole is defined by the centrifugal force that causes the black hole's horizon to bulge out into an ellipse. The very same centrifugal force transforms the singularity into a ring. The outer and inner horizons form confocal ellipsoids with the ring singularity at the center. However, in reality, that mathematical situation will not exist. Other estimations in the past proposed that the singularity is a truly whole surface inside the event horizon. We simply do not know if it is possible that singularities do not exist in real black holes. There is also a theory that says matter does not get mooshed down into that endlessly tiny point called a singularity deep inside of a black hole. Instead, it could exist as the smallest possible pocket of volume or as the minimum possible configuration of matter. A space-time singularity is a time singularity, and you should consider a moment in the future that you cannot avoid. This is a Planck star, and is a theoretical possibility envisaged by loop quantum gravity, which is a highly speculative suggestion for constructing a quantum version of gravity. In the loop quantum gravity world, both time and space are quantized, and the universe that surrounds us is made up of tiny discrete chunks. However, at such a tiny scale, our movements have seemed smooth and continuous. We don't know if what we're seeing is in 2D, 3D, or beyond all there is to see unless we discover a way to gather information from the bowels of a black hole. If the most recent calculations are correct, an existential question arises. What happens to the remainder of the universe if, indeed, the black holes are holograms? At the moment, there is no clear answer, so we can only say yes or no. Of course, holograms are simply two-dimensional pictures created with lights for us in three-dimensional space. However, in this case, Rinaldi and his co-workers are referring to a black hole's interaction with its surroundings. The universe, on the other hand, is a unique case. But what if the image was three-dimensional and projected in four-dimensional space? Would it also produce a hologram? When relativity and quantum physics collide, black holes represent the point at which our universe ends and folds back on itself. We just have to find out how to link the two moments, and we might be able to find a coherent theory to define the universe. As it turns out, they not only consume and severely damage everything which falls into their path, black holes can also keep spitting out hot matter fountains and surround themselves with firewalls. It's a good thing our solar system doesn't have any black holes yet. According to one source, black holes can also move. What if it gets too close to our solar system? Do you have the courage to dive into a black hole in the search of the answer? Let us know your opinions in the comments section below.